Hello and welcome to Postgres FM, a weekly show about all things PostgreSQL. I am Michael, founder of PG Mustard, and this is Nick, founder of Postgres AI. Hey Nick, how's it going?
Going great. I'm very glad to see you. How are you?
Likewise, I'm good, thank you. And you chose the topic this week. What are we talking about?
Yeah, I think it's very interesting to discuss the level of automation we have in terms of all. You know my position against managed Postgres, and in this case, it probably will be opposite, saying that it's not enough what we have in terms of managed Postgres, and also in terms of Kubernetes operators and other automation projects Postgres ecosystem has right now. So why I was thinking about it? Imagine in 2011, Heroku was started. Heroku Postgres was started. 2013, RDS Postgres was released in November, I think. And at reInvent, I guess, right? So then this was a foundation of growth of interest, I think. Like some people say it's because of JSON or something. Like I agree with those arguments, but I think the central reason of why Postgres started to grow in 2014, 15, and by now is that before that, backend engineers, developers, they were always complaining how difficult it is to set up Postgres and configure it, and backups and replication that just didn't want to deal with it. And RDS and Heroku before that, they brought automation for basic things, right? And this, I think, simplified lives of a lot of engineers. That's great. In 2020, Supabase was released. And I think a new wave of audience was brought to Postgres ecosystem, front-end people actually. Because now it's not only Postgres automated, it's very well automated. Other components are very well automated, like REST API, real-time component, right? These things, authentication component. So you immediately start working on front-end, forgetting about back-end. So I admire Supabase for bringing a lot of front-end guys to Postgres. That's great. But at some point they need to learn SQL, I'm pretty sure. So this is fine. And now we have AI builders, and this is another wave of users and basically not humans already sometimes. So we hear from Supabase and Neon that a lot of clusters which are created these days are created by AI by request from like Cursor or something, vibe coding, right? And so many clusters, many of them are small and maybe won't go anywhere because it's just experiments, prototyping and so on. But some clusters grow and they lack attention. So with RDS, there was a big shift. We talked about startup teams who don't have DBA, and they are fine with it until some point. And this is where Postgres AI professional services catch them, right, quite often. But now we talk about even lack of backend engineering team completely, for example, with Supabase, or even without like lack of engineering team completely somehow, right? And only guys who understand product and try to vibe code this. Sometimes with security breaches, like recently some app was like storing data in Firebase, right? Google Firebase, and it was not secure at all. 5 million users registered. That was a big scandal. So yeah, anyway, but this is part of the topic security. So what I feel is demand of much higher automation than just RDS or Supabase. Some new level of automation should be present. And if we look at enterprise sector, there's Oracle with this idea of autonomous database, self-driving database for many years, right? On one hand. And on another hand, there are academic papers like one from Carnegie Mellon University and Andy Pavlo from 2017, which discusses what self-driving database management systems are. And there's a question. If you think about zillions of Postgres clusters which should be highly automated, and when experts look at them, everything should be already transparent and obvious how to fix and move on. What is this? Like, what is self-driving Postgres? I was thinking. And to answer that, I performed several waves of research, of course, with deep research from Claude and OpenAI or ChatGPT, right? Latest models. I paid to everyone a lot of bucks already. So I was thinking, what could it be for Postgres? To answer that, I performed research looking at Oracle first of all, and I just asked deep research is when they perform Google searches or Bing searches and analyze hundreds of sources and then write some kind of report like some student would write. It might have issues, of course, with report, but it gives you a lot of links at least and some summaries. So my question was, what people, after all those years of building autonomous Oracle, what do people really like and what they like less, right? Like,
what did you find? What did they say?
Yeah. And one more comment. In 2013 or 14, I think I was attending Autonomous Oracle webinar, and I was completely shocked. They promised Autonomous Oracle, but they've only talked about clustering in the logs, organizing like better log analysis from hundreds or thousands of sources and not only database. And I was like, where is Autonomous Oracle here? And 10 years since then, almost more than 10 years, I was thinking it's like stupid. Now I changed mind, and I hope you and our audience will understand why. So what I found is that people appreciate a lot self-patching. It's like meaning minor releases, like if new release comes out with security patches, it's not a headache at all. And this kind of automated RDS, you can just define maintenance window, with some caveats.
Minor versions only, I think? Or have they done major versions now?
Major versions, automation of major version upgrades. And here we definitely have something to discuss. I mean, we discussed it already. And I mean, my team, we had very good recent cases where our customers had zero downtime upgrades. It's like, and we were very happy. I hope some blog posts are coming.
Zero downtime is very different to fully autonomous, though. Like very, very different.
From fully autonomous,
or self-driving major upgrades is very different to no downtime.
Let's do one more step back. What is self-driving car?
Yeah, great.
There are 6 levels defined by SAE, like kind of standard or something. So there are 6 levels from 0 to 5. 0 means not autonomous at all, manual, regular car. And then 5 is fully autonomous. And looking at first few levels, I realized interesting things. So they talk about not each feature particularly, but of combination of features. For example, level number 1, it could be either adaptive cruise control, like so maintaining speed but safely, right? Or maintaining lane, but not both. If it's both, it's already level number 2, right? And there are several levels. And for example, this paper, Carnegie Mellon, Andy Powell's paper from 2017, it discusses how to map it to database management systems, right?
Well, so, a little bit, not much in my opinion, but a little bit, yeah, for sure. And this paper, I looked at this in advance. You shared these car things. I'll link them up in the show notes as well. It struck me that level 4 to level 5, so the last step, is a huge jump. Like, it's like, here's loads of features in the car that will help the driver, and then level 5 is suddenly, and now the driver does nothing. So it's like, that feels to me like a whole, like maybe a potentially huge chasm, that maybe there's like 100 more levels in between 4 and 5 that we're going to need to break down at some point. But like, I felt like it was a very hand-wavy way of saying we might be really close to this, because we already have level 4 features. We're very close to having level 5. And it feels to me like there might be like I was unclear, for example, in a level 5 car, whether a human could still take control if needed, or was there absolutely no way of doing that? Like that feels to me like a level that wasn't defined, and maybe there's like other, I believe there'll be,
let me explain how I see it, and I think if you ask several people, they will answer differently. And I also heard Kubernetes ecosystem tries to map it as well. And some operators, they claim they have a very high automation, but many people say they don't have, and so on. So in terms of cars, let me propagate it. So number two, both these options, for example, and this is what Tesla Autopilot, for example, does. I use it a lot. You just you turn it on, but you must sit and keep, basically, officially, you must keep hands on wheel and be ready to take control any second, basically, right? But it's still, it's great. It maintains lane and speed. You just relaxes and spend much less effort. And I think we can think about this in databases as well. Next level is level number 3. And level number 3, it's everything is automated, but you still need to be ready to take control. And this is what, for example, Tesla full self-driving is. Well, this is not everything automated. It's under supervision of you.
I've just pulled it up. No, it's not quite that. It's level 3, it says here, for example, is a traffic jam chauffeur. So it can handle basic traffic conditions like a traffic jam. But it, for example, it doesn't account for all weather conditions, or there's a bunch of other potential things. So it's not
there are limitations.
Exactly.
And you still need to take control if needed. Basically, you need to be ready to take control. This is level 3. I agree. So there are limits, but it can bring you fully automatically from point to point. This is what Tesla full self-driving does. You sit in driver's seat, and from point to point you can you can enjoy full automation of some whole ride. But if some bad condition occurs, then you need to take control and fix things. This is, for example, if we map to full major upgrade, downtime, and so on. By the way, when we think about autonomy, we also bring some additional features like zero downtime. It's it could be in place and with downtime, but somehow our mind wants some good features additionally to autonomous. So this is natural desire to have good stuff, But we can imagine, for example, we have a whole thing automated, and under many circumstances, in many cases, it will work. But in some edge cases, it won't, and you will need to take control and make some decisions before proceeding on, or even postponing the whole procedure. This is very similar to Tesla full self-driving, and I experienced it. It really can drive you from point to point. But for example, if you go inside, for example, my property, I have some roads inside it. It won't be able to drive there at all because this is already not a road, not proper road, So there is another level, 4. It's also conditional, but there what my perception again might be wrong. There you can go to backseat and sit there. You are allowed to relax completely, fully, but again, it will work only under some conditions. For example, there is Waymo. I tried it multiple times in San Francisco. It's amazing. You go to its Jaguar, you go to backseat, and everything is fine. But if we saw these YouTube videos or something, multiple Waymo machines, cars, they just create traffic jam themselves and basically deadlock, right? So if they sense that they can't drive or they spot something they can't deal with, they'll stop as a safety precaution. But then what do? You have to get out? In this case, yes. In the case of Waymo, you're a passenger, yes. So you can imagine, for example, if we map it to major upgrades, for example, imagine there is a procedure for develop. There is a vendor who can intervene and can take control sometimes if allowed. But the passenger, in this case, those who asked to perform full major upgrades, they are passengers. They cannot make decisions. But this is good for them because their mind is spent for product development, for example, right?
Yeah.
But thanks to million miles already of experience and real life experience of these cars, if something goes wrong, safety first, it will just abandon the trip. Postpone it and cancel, and another car will come later, right? So this is approach. But it's whole thing encapsulated, like black box for you, right? You don't go down and don't make decisions according to some diagram of decisions, right? And then, but it has also limitations, and I think Waymo is a perfect example for level 4 because it works in San Francisco, in some areas, but you cannot drive to San Jose, which is like slightly more than 1 hour usually drive, because it's outside of coverage. And this can happen here as well, major upgrades, but if if there are some extensions, for example, it's outside coverage, we don't support this kind of upgrade because this extension, like, I don't know, Citus or timescale DB, it requires an additional approach, and we don't have it covered here, right? So this is what I think here, like we can map it, and why not? But my main insight was looking at deep research of feedback from Oracle users, DBAs and engineers. They say upgrades are great, both minor and major. Security is great, like security control, automatic procedures to level up security. These kinds of maintenance things are great. But when we talk about smart, like index advising and so on, it's a hit and miss situation. Yeah. And this, I had an aha moment because I was thinking, actually, if you look at what all people try to do, they try to invent configuration tuning automated with machine learning and AI. This is what Andy Powell was doing with AutoTune. And by the end of AutoTune was closed, but by the end of AutoTune Live, I already noticed the shift which happened to Postgres AI earlier, attention to query tuning and optimization, like creation of indexes. And I see PG Analyze is doing a great job, not resisting to LLMs, which is also great. And also some teams go inside Postgres and try to make planner smart. And I had, like, with configurations, pretty straightforward for me. It's Pareto principle. Take pgtune leopard com.ua, very simple configuration, 80% of job done in 1%, like really, really fast. It's just heuristic-based, rule-based approach for LTP or like anything. And it's good enough for many. Like we don't need any machine learning and so on.
And even, mate, when you say for many as well, I think it's also about time. So it's for a while, it will then be good. So for longer, it will be good enough. So
I agree. I agree. And then you need to tune. And my way of tuning is to conduct experiments. You know this very well, like how to make experiments faster, cheaper, reproducible, and so on. Like these kind of things.
Is it worth, because I think self-driving, like probably level 4, many people would count as self-driving, but there's still the kind of enough caveats that a lot of the benefits of self-driving cars, let's go back to cars briefly. I'm really excited and optimistic about self-driving cars. I love the idea of being able to get on with something else while something drives me. I don't mind that it might not be like the fastest way, or like it might not drive like completely optimally. It might not even pick the route.
Not the safest. What about safest?
No, probably the safest, but not the fastest. Sorry, like probably safer than me, but maybe it would be a bit more gentle. You know, maybe it wouldn't take the yellow light when a human driver would. You know, that kind of thing. But I love that you can just watch a movie or chat to a friend easily, or play a board game in the back. You know, you can do whatever you want. You get so much time back, especially in America where a lot of time is spent driving. It makes so much sense to me that self-driving cars are like a huge unlock for a lot of people, but largely only at stages 4 and 5, like at that highest level. Like cruise control's great, but I still have to concentrate. Yes. I still have to be watching the road. Like I don't actually gain that much. And if we go back to Postgres, I feel like a lot of the automation features are great.
Yes.
But we still have to concentrate. We still need the person. We still need the DBA. Well, and as long as we still need the driver, and as long as we still need fail-safes down to humans, all I see is kind of this like gradual need for maybe this is where the driving analogy breaks down a little bit, but maybe fewer humans per server. To like maybe the DBA team for a company will be smaller on average compared to how it was in the past. You know, and I think we've already seen that over time. But I'm struggling with like the that last step until we get to those, which feels to me like a long way off, especially given like the experience you're saying about like Oracle and the experience we saw with very smart people trying to automate a lot of this stuff from, with a lot of AI, but kind of not even LLM stuff, right? Like a lot of the research in this area has been machine learning and like other longer researched AI methodologies that have lots of real world use cases. And even there, we've seen mixed results, and it really, I feel like the model's struggling to, in the experience I've had talking to customers that use Autotune, for example, I feel like the constraints, for example, were not as clear as driving, or the slightly different use cases, or the performance trade-offs that different people have in different cases are subtle enough that you can't set the exact same guardrails for everybody. And at that point, it breaks down enough that, one more addition, performance cliffs are so real that if you change one thing and it looks like it's going to be great, as soon as you hit a cliff, it's then a disaster. And then recovering from those disasters is actually a real problem. So, and I feel like
troubleshooting disaster is also a problem. Root cause analysis is a problem.
And arguably they get harder when you involve automation, because the more that it's automated, the less people actually know what was changed when and why. So I think it can get tricky. I
disagree here with you, because
okay.
You must be an expert. But if you have automation, you move much faster with a high level of automation. Take Cursor, give it a lot of pieces together, and explain how you approach methodology of analysis. This is like expert needs to bring, and then you move much faster. So, but this is like I was trying to explain how I moved to this area completely, right?
Yeah. Okay.
So people say, in Oracle, this works, that one doesn't. What works? Quite simple things. I said like upgrades, maintenance, security stuff. Well, not simple, but they are boring, Of course, replication and backups, like for me, HA and DR, it's like auto steering and maintaining speed and maintaining lane, Basics. Cars must do this, so database must have good HR and DA. If we look closer, actually, there are issues with both the HA and DR, which will prevent us from reaching very high level of automation. But we can dive into this later. But anyway, boring stuff lacks automation. Interesting, like remember I mentioned level 1 and 2, they talk about combination of features. So if we start analyzing each feature particularly, we cannot apply the same classification, because classification talks about combination of features.
Yeah, sure. What going back, actually, just to make sure I understand, what have Oracle done in terms of security? Can you give some example automation features?
I know a little. I would say what we should do in Postgres, and this is like least topic I would like. I'm ready to discuss now, because this is in the roadmap, but right now we're focusing on different areas. I can just speculate on this, identify potential threats, like checking permissions, roles, for example, I know organizations which use the same super user for all human DB engineers, and this is quite easy to identify. Or any organization, I had a couple of them on consulting contracts, which passed through IPO process. Before that, you have audit, right? Yeah. And during audit, they ask specific questions. Some of them are quite silly, I would say, but some of them are quite good enough. And you just inspect your PGHBA conf, you inspect user model, you inspect how multi-tenancy is organized. We had an episode about it, right? So these kind of things can be automatically analyzed and so on. I don't know details about Oracle. I just saw feedback that this stuff engineers really appreciate, and they appreciate less automated configuration, automated creation of indexes. And this
appreciate less, or it gets it wrong. When it gets it wrong, it's more painful. Do you see what I mean?
Mixed results. There's lack of trust in some minds. I don't know. Yeah.
I, for example, I catch up with customers from time to time just to hear what they're doing, what they like about products, what they don't. And I was speaking to a customer of mine that did try and use Autotune for a while. And it'd be interesting. Maybe we should invite somebody from that team on to discuss
From
like
Autotune?
what happened there. Yeah, why it failed. Like, why did it shut down? Like,
I can
what
tell
was
you
the...
why. Like this
on.
people don't need configuration tuning that much.
Okay, well, I also think there might be other issues. So there's definitely like a not needing it
I
much
tell you, the big
issue.
need in configuration tuning exists only if you have, for say, 10,000 plus clusters. Then you can say, okay, we are going to save like 5 to 10% of money just with tuning, or workload will be reduced. We know you know very well. Really bad plan can screw all efforts of configuration tuning.
Well, yes, but I think it's worse than that. I think also, in addition to it not being needed that often, and therefore kind of subscription-based models not working that well, also, this customer was telling me, they moved from a mental state of when something goes wrong, let's dive into what happened, straight to when something goes wrong now, what did Autotune change? And that was like a real shift. It became like a trust, but also that must be based on the fact it made changes in the past that made things worse. So it's not trust for no reason. It's not kind of like not distrust for no reason. It's every now and again, if you change something, you hit a performance cliff, and it's unexpected, or maybe it's not even like always a performance cliff. Maybe it has another unintended consequence that you care about more. Like, probably not in a lot of these cases, but I think they talked about, for example, making the mistake of letting it configure some parameters that even affected like durability and things like that. So if you're changing, depending on what you allow it to change, there might be unintended side effects. And I think that's like putting parameters around like what you will and won't let it do is actually harder than it sounds. I think like
it's very hard to perform in like enterprise approach for making a change. It's extremely complex. I'm very grateful that 7 years ago I was working with Chewy. They were preparing for IPO, and I remember CTO was ex-Oracle, and discussions we had and resistance they had in any change I proposed. It taught me this enterprise approach. I'm very grateful. It was great experience for me. And I realized, actually, if you want to be serious about changes, any small change should be very thoroughly tested, experiments. All risks must be analyzed, and then there should be a plan to mitigate if unknown risk occurs, right? And AI doesn't help here almost, this is framework you need to build without AI first. But
I don't necessarily agree. I think AI could really help with these things. When I say AI, I'm including machine learning and not just the latest LLM stuff. I just think we need to define constraints really clearly and define what we care about really clearly, and make it really clear we care more about reliability and durability than we do about performance. So
yes.
And that's almost always true. And I think that might be more core to the reason that these performance tuning tools haven't yet succeeded, because we haven't yet nailed the reliability, durability stuff.
Yeah.
So that would be my theory as to why they didn't necessarily succeed. Because if we help, even if they did help performance almost all the time, if they ever hurt reliability, that's not a trade-off most organizations are willing to make. And that's a difficult thing to tell a tool that's trying to optimize for better performance.
Yeah, I agree. And durability has issues. There is a good article from Sugu just published on Sugu's blog about synchronous replication issues, and we also know the very good talk by Alexander Kukushkin about issues with synchronous replication. So durability is a must thing to have, and targets. I agree with you. Targets, durability, availability reliability must be number one before performance. By the way, I also remember from that research, people appreciate automated analysis and control of costs.
Yeah.
And this can be initially quite simple. Like if I remember actually talking to one huge organization, their database director told me, you know what, it's cool stuff, what you're showing in terms of experiments and performance tuning and like query tuning experiments with DBLab and so on. But the number one problem we have is abandoned instances and how to stop doing that and lose a lot of money. And big organizations, it's a very big problem. And so cloud providers still don't offer good tools. It still takes a lot of effort to understand the cost, how the structure of spending, right? Proactively, like usually it's already too late. They are not interested, yeah, right? So anyway, what my aha moment, back to it, was people like from academia, from really great people, right? Great minds. They try to build really cool stuff.
Yeah.
Like let's have automated parameter tuning, automated indexing, or even let's go inside Planner and create an adaptive query optimizer.
I saw even more extreme. In the paper, they were talking about choosing whether tables should be row oriented or column oriented based on the workload they're observing. So it's like trying to attack really cool areas.
This is great, and this has been always so. Academia guys, they attack like really detached from reality things.
Yeah.
Meanwhile, I realized we implemented with multiple teams already automated indexing, and this is what people really need. And lately, I realized in consulting, we almost always say you need automated indexing, but we didn't have polished solution. We have multiple ways to do it, and I always said you take this tool like someone from our team developed like as a side project and then polish it. And it's only about bit-tree indexes and this and that, like and also estimates, bloat estimates might be off. We know very well if there are estimates, not just stat tuple numbers or real vacuum like reindex numbers from a clone, right? And I realized actually this problem is not solved, and this is boring problem, and we can solve it. That's why number one thing right now we are going to release. We already it's about to be released. We call it PG Index Pilot, and there is a good roadmap inside it. It's a whole project, and it's going to be real simple. And a guy who part-time works with me right now, Maxim Baguk, one of the most experienced DBAs, Postgres DBAs I know, much more experienced than I. He created basically I consider prototype. I said we fork it and then we started iterating on it. The idea is simple. I call it Baguk number. So you take index size, divide by number of live tuples in this table. Let's forget for a while for partial indexes, and we have some ratio, right? When we just created index, let's consider this ratio as perfect, and consider tables which exceed, like say, 1 million rows. Over time, you will see this number is nothing. Like it costs nothing to check it. You can put it to monitoring for all indexes. It's super fast to get a number of
because these aggregates
couples.
are stored. They're stored, right?
Yeah. It's from system catalogs.
views.
Immediately you get it, and then over time you see degradation of this number.
Yeah.
Why? Because some pages inside the index they are not full, right? They're half empty and so on. Like they're sparse.
Yeah.
So it means at some point you say, it's time to reindex. And there are pros and cons of this approach compared to, like, say, traditional based on bloat estimates everyone is using. The big a couple of big cons of this approach, it required us some effort to get away from super user. We did it. And, one more thing. On purpose, we said this component is going to be inside, like self-driving, inside database. We don't need external means like something installed on EC2 instance or lambdas. We don't need anything. It will be inside. This means it's running inside PLPG SQL code. We know since Postgres 12 or earlier, stored procedures have transaction control, right? So we can go, but we need index concurrently, right? So with index concurrently, we cannot wrap it inside transaction block. So unfortunately, we need something like DB-link, right? And it's a challenge not to do it properly on RDS, for example, because DB-link you need to expose password, and this is not you don't want to store it in plain text. So I remembered very old trick I used a lot of years ago, DB-link over Postgres FDW, and this is how we do it right now. And there is another limitation. To start this thing to work, you need baseline, right? So baseline means you need to index everything first, or to bring this data from clone, which this is an idea we are going to implement very soon. So to avoid the full index, because sometimes our customers have like 10 plus terabytes databases, and it's not cool to ask them to index. It will take forever and so on. There's also a big impact when you index quite fast. So, but good benefit from this approach, it's not only about B3. It's not only about B3. You can take care of Gene, Gist, and even HNSW and others if they degrade, and like basically, basically we measure kind of storage efficiency for index. It's super trivial, and I believe into this simple approach. I think we are going to have it. And I think also, like I talked about this last couple of weeks ago with Andrei and Kirk on Postgres hacking on Postgres CV, and we started doing something mind-blowing. Andrei just said, let's just implement merge, because B3 and B3 implementation in Postgres, it has only split. It cannot merge pages. And since Andreas' PhD and so work is in the area of indexes, it was great to have to have ability to start this work, and I'm looking forward to like everyone.
Wait, so like if, for example, an area of the index starts to get sparse because we've deleted a bunch of, let's say we've deleted some historic data and we're not going to insert historic data back in that part of the index. It could proactively, it's kind of self-healing then.
Exactly.
You can merge those. Wow, cool.
So our project would be archived at some point, I hope. So I'm not an expert in Oracle, since I have never been expert of Oracle, but also not a user. Last version I used was in 2001 or 2. It was 8i. It was so long ago. But people say Oracle doesn't have this need in the indexing. SQL Server, I heard, has this need. You over time have declines. We talked about it so much. I said this is mantra. Everyone needs indexing at some point. And we know Peter Gagan work and Anastasia Lubenikova in 13, 14, they implemented deduplication and other improvements. That's great. But still, there is no merge. So pages cannot be merged automatically.
And there was some work, there was also some work, I think, from Peter Gagan and others to help avoid page splits in more cases. Not just the deduplication work, but the bottom-up deletion. So avoiding them getting into this state was one thing. Helping them heal when they do is another. It also strikes me as a lot of this stuff could live in core, right? We already have some automation features, right? We already have auto vacuum, which does about 3 or 4 different jobs. So we have some groundwork here already. We have tools like PG Repack and PG Squeeze, not in core, but some ideas of moving more of their features into core. So we do have some of this in core, some of it in popular extensions that are supported by many clouds. So that feels like the project is already naturally going in this direction. Maybe slowly, and maybe not all the areas you want it to, but is that what does the end goal look like here? Is it being in core ideal?
Well, in my opinion, we just need to solve very complex problem. I know in some big companies manage Postgres services, sometimes one experienced DBA is responsible for 1,000 clusters. 1,000. It's insane. But we need to be prepared to be responsible for 1 million clusters, because AI builders will bring us a lot of clusters. The time changing really fast. So Postgres need not to lose the game. By the way, right now, if you check Hacker News trends, it was growing, and not only about job postings as I usually mention, but everything, all discussions on Hacker News. It was growing until the beginning of last year, 2024, and then we have slight decline. And I think Postgres has right now a huge challenge. It needs to be much more automated. If things needs to be in core, it should be in core. But not everything should be in core. We know auto failover is still not in core, right? Patroni, right? But Patroni. I just asked Kukushkin, has he considered automation of post resume and switchover without downtime? This is what people want and expect for highly automated system. He said no. And I started making joke because I said Patroni is outside of Postgres because it's not the job of Postgres to do HA, auto failover. And now I expect you, Patroni maintainer, to tell me that automatic switchover, zero downtime switchover is not job for Patroni, so I need to implement another layer on top of it, right? This is what actually we do already. For zero downtime upgrades, we do this. And by the way, I can share this already on our consulting page. We mentioned GitLab, but also Supabase and also Gadget.dev. These companies took tech from us, and I have official quotes from their managers, so I can share this news. I think we developed really great automation for zero downtime upgrades, which are not only zero downtime, but also, of course, zero data loss and reversible. And reversible without data loss as well. So these are perfect properties, but it requires a lot of orchestration. Fortunately, since Postgres 17, things are improving and less pieces need to be automated. So let me go back and explain my aha moment finally and my vision what I have right now. I realized that boring stuff needs to have much higher level of automation. This is one. Second, I realized Postgres CI team, this is exactly what we are doing because with consulting, people bring us these topics. And I realized also that in every area, if we think about automation of feature, we can apply a simplified approach for classification. So if every single step must be executed manually, like CLI call, like pgdump call or something, pg upgrade call, or SQL snippets, if they are to be executed manually by engineer, this is manual, right? If there are bigger pieces, which like say whole procedure consists of 2-3 big pieces, and they are combined, like, and engineer only makes choices to proceed or not between pieces. For example, our major upgrade consists of 2 huge pieces. Physical to logical with upgrade, they are bundled due to some reasons, specific reasons. And switchover, 2 big steps. And inside them, there is high level of automation. You just call playbook, it executes, right? In this case, it's already can be considered level 1, say, right? Say level 1 or like 2 maybe, I don't know. And then if we can fully relax and go to passenger seat, and just say, okay, I approve that you need to do everything, but you will do it yourself. I mean, Postgres or additional system will do everything yourself, like full major upgrade with switchover. In this case, like say at level 2, and you're on passenger, but there are limitations. If it will encounter some problem, it will stop, revert, postpone, and you need to approve things. Highest level, if this feature, like if system decides, oh, it's time to upgrade, and then it schedules it, like, oh, we have low activity time on the weekend, and you even like you are notified about it, you probably can block it, but it moves on itself. This is the highest level of automation. And for back to reindexing, which I chose this as lowest hanging fruit. Everyone needs it. Nobody in Monk managed. Maybe after our episode, people from RDS Cloud SQL, I know some of them are listening to us, will rush into implementing this. I just see everyone needs it, nobody has it. In terms of managed Postgres, nobody offers it. So I am highest level automation for PG index pilot right away. So it will decide when to reindex, it will index, it will control activity level, so not to saturate disks and so on and so on. You can check roadmap. I explained it in README of this project, and this is open source. Because I actually truly believe at some point it won't be needed, this project. If Andrei's idea will work for merge, maybe. I don't know. This is a dream, right? So forget about index bloat. Right?
Yeah.
Yeah. I guess it will be super hard. I tried to research why it hasn't been done, and I didn't see why. Like maybe it's scary. This is basics, like foundation of whole Postgres, of any cluster, right? B3.
Yeah, well, I guess when would it be done? Would it be done by a background worker like Auto Vacuum, or would it be like, at what stage does it make sense to do?
Well, it should be synchronous. Oh, I know, this is a good question. I'm going to ask Andrei about this. Yeah. Because split is synchronous.
Yeah. I also think the thing you brought up just at the end there is super interesting, like controlling the rate to not saturate disks. Like, this is an interesting thing with trade-offs again. Like, if you're on Aurora Postgres and you're paying some amount per IO, like for, you probably don't want your indexes rebuilt constantly all the time. What you really want is to fix the root cause. Like, it's probably an application issue. Like, why are you updating the same row thousands of times a second? Or like, what's the root cause of the bloat or the? So
we just had a case of updating multiple times a queue-like workload. This can be identified. Yes.
Yeah. So I'm excited to see what you build. I think you're right that more automation in Postgres would be good. More automation in extensions around Postgres would be good. But a lot of the issues I see are kind of application source issues. And even if we make Postgres completely self-driving, there is still this kind of application level issue that will be...
Mistake there can put all your efforts to ground,
Yeah, exactly.
I agree.
So
that's why in our, I identified 25 areas in my blog post a couple of weeks during our launch week. Maybe we will adjust those areas, of course, it's not a final list. And we are targeting 3 right now. Like, I hope we will expand this list to 5 to 6 next year. Once we have quite good building blocks, we will think about whole system. But the central part of all these building blocks is new monitoring system, which is good both for AI and humans. And this is what we are already actively building. We replaced all our observability tooling used in consulting with new monitoring system, which is called Postgres AI Monitoring. We talked about it separately, right? And this is going to be like the source of insights why things are wrong. And then we cannot self-drive application yet, right? Although in some cases might be so. Because if, for example, Supabase, they control not only Postgres, but also REST API level, right? So some things might be done there. But in general case, we cannot. So in this case, we need just to advise and so on. But eventually, things like serverless, like Vercel workloads or so, I see they can be together with database eventually. In this case, we can discuss full self-driving something, right? But we are very far from that, I think.
Yeah,
and we have limited resources. I wanted to admit that I'm targeting very narrow topics right now. So very boring, but really doable, and we see demand. Like things like partitioning, help with partitioning. It's nightmare to do it for arbitrary engineer. We say, declarative partitioning. But for example, partitions are not created automatically. Okay, there is PG partment, but you need to combine these pieces, something like the level of automation there is terrible.
Yeah, but these are the kind of things I'd love to, like a couple of things. I'd love to see more of this go to core. I think there has been improvements in partitioning in core, many over the last few years and continuing. And the other thing is, I think there's a lot of focus on fewer people. With this automation, a lot of the focus is on we can do more with less humans. And I'd love to see more effort into what would happen if we didn't try and reduce the humans, but instead try to increase the reliability, or you know what I mean?
Exactly,
like actually,
exactly.
And I think there's a lot of talk about how do we
Speaking
cut
of
costs
partitioning,
and not enough. Yeah,
we have already, I think, 5 companies who are very fast growing AI companies. very well known already.
Yeah.
And I see a very different approach to Postgres. For them, it's a natural choice, like let's start with it. But then we need to partition terabyte size tables. Let's estimate work. Oh, that much work? Okay, maybe we should migrate to a different database system. They're moving really fast. And they're not like attached to Postgres, basically. So I'm scared about Postgres. That's why, like I'm saying, automation, there should be a massive shift right now. And resources of my team is not enough. So that's why I'm talking about it. I'm going to put whole focus on it. During consulting, we also choose only paths that are fully automated, like highly automated, fully automated. And I'm looking for some use cases, more maybe partners who think similarly, right? This is a call for Postgres ecosystem. Like it's not enough right now. Like we're not. Postgres might lose this game again. Like Postgres won multiple challenges, like object-oriented, NoSQL, but AI. Everyone thinks about AI only about like PG vector or storing vectors. It's not like. Not everyone needs vectors. People like build some app and it needs database, maybe with vectors, maybe without vectors. But what they expect is higher level automation, scale easier. So I'm super happy to see new innovations in the area of sharding, right?
Yeah, I think that's actually more. I do think that's more important, partly for just the marketing story.
Than partitioning
for those. Yeah, because I think we talked like. If you think about partitioning, I think, for example, when we spoke when we had our 100th episode and spoke to Notion, Figma, and Adyen, Notion skipped partitioning and went straight to sharding. They decided that with all of the partitioning downsides, and then there are quite a few limitations for their multi-tenant architecture. It actually made more sense to shard instead of partition. And that felt like it wasn't one of these things where they were moving super quick and made a rash decision. It felt like a really considered engineering decision. And I actually think it was the right call. And I wouldn't be surprised if with more of these sharding, if more of these companies are coming in and building fairly seamless sharding that doesn't add any complexity at the application level, I could see people tempted into that, even if it wasn't for good engineering reasons, just for the marketing reason of, I don't have to think about scaling this, and I don't have to do it with terabyte tables.
You know this normal distribution meme, right?
Yeah.
Usually it's like unexpected on the right side, where is expert. So I don't know in which camp I am. I was thinking Postgres one node is cool enough. Then I was thinking it's not cool enough because of performance cliffs. Now I'm thinking maybe it depends, because in some cases, it's much safer to avoid all performance cliffs, not just allowing like 100,000+ transactions per second on one node. You just resiliency, right? If one node is down, only part of it's just one shard, right? Maybe yes, but at the same time, it's so cool to see projects which require only one node. They are isolated. They don't need a whole bunch of shards and clusters cluster of clusters, so cluster term is heavily overloaded, right? And you think, what's really power to have just one single node? Sometimes without replicas. I see projects without replicas, because cloud times change, right? And I think I'm open. I know my perception over years changes. Sometimes it's a pendulum. So it depends. Regular answer, normal answer from consultants. It depends.
Yeah.
But sharding, it's really great to see that it's coming from multiple teams. There will be competition. So here the future looks bright. But who will be helping to choose proper schema for sharding?
Well,
and rebalance properly normally. So I think they who build this think about this as well, automation and to choose time for rebalancing and fully automated.
Well, we talked to Sugu. He said it's inevitable that you're going to have to change your sharding scheme at some point. It's just designing for that up front seems really important. Vitesse handles it. So yeah, interesting times ahead. I'm a bit worried about the complexity of these systems. Like, personally,
Let's
I
start
quite
with
like
simple things. Yeah.
yeah, starting simple, but also I like the idea of, if I'm a Postgres user, I can still understand the system, like roughly what's going on, even if I'm a full stack developer, even if I do the front end, the back end. Like, I know it is already very complex. I know there's already a lot of internals that you kind of need to know about to make a performance system, but I hope we can hold on to that for a while at
Well,
least.
I truly believe that what my team does is going to help, because we observe many problems, and every time I'm saying, guys, like, we need to write down some how to, and so show with experiment so users understand like what's happening. Write some how to for next time, right? And when we're writing how tools recently, we write it both for humans and AI. So next time some RCA is happening, root cause analysis is happening, if you have our how tools injected to your cursor, for example, it's going to take into account some situations which are written and how to reproduce them, how to troubleshoot them, right? So I think something else is coming. I'm not going to spoil it, but RCA and troubleshooting is one thing we will attack early. We are preparing pieces for this, and one of key indicators of success here is that non-experts understand what's happening, because
that's the area that I specialize in. I'm actually betting a little bit on humans staying in the loop for quite a long time, and that there will always, well, not always, but for a long time, there'll be categories of issue that we still need somebody to look into.
Yeah.
And I kind of feel like the level of Postgres knowledge is the median level of Postgres knowledge for people having to look into those issues is probably going to go down. Like, based on all the trends that you're talking about,
maybe yes.
It depends.
Maybe
If we only have a few experts that are shared between lots of companies, maybe that's not true. But if we do have a lot of individuals starting with vibe coding, or starting with like doing a full stack kind of single person companies running the whole product start to finish.
Yeah.
Those guys, like, they have to know a lot about a lot of things. They can't know that much.
Have you seen numbers Superbase shared, how many clusters they register and how fast it is?
Yeah. But that's kind of my point.
Can you imagine how, like, average knowledge of Postgres there? Yeah? But
exactly.
The idea is, my vision is that with AI we collect knowledge pieces, we experiment, automate experimentation, and so on. But then, obviously, this is what I see with our customers. Some human is needed to explain properly to other humans, to answer questions properly, to build trust and confidence and so on.
Yeah, but my question, I guess the question then is, where do the tools live? Like, can the end user use a tool to get help? Like, or does the Superbase team use a tool to get help? Or does the consultant that the Superbase team employ,
my answer
who's
depends.
the tool for? And I know, I'm just saying that, like, it depends who you count as the user in terms of how much their Postgres knowledge is. But I'm talking about that end user.
Yeah. For example, with DB Lab, we already went this path. We moved from a couple of guys answering all the details backend engineers have in terms of how plan works and what to do about it, which index to create. We now have DB Lab backend engineers experiment themselves. And if something is unclear, only then they call an expert and for help, right? But like 90% of questions answered by backend engineers without involving Postgres experts, And expertise in backend engineering minds grows as well. I'm just thinking this approach we had for query optimization can be applied at grander schema for many other areas. Yeah.
All right, probably enough for today.
Thank you so much. We went much deeper in specific areas than I expected, and I enjoyed it a lot. Thank you so much.
Nice. Catch you next week.